All right, midpoint, Riemann sum. Length of 2, using the midpoint. So I'm still going from 1 to 7. Since it's being recorded, I should hear productive conversation from you for Aleena. Here is length of 2, width of 2. Go up, touch the function. Length of 2. Go up, touch the function. Length of 2. It's already touching the function. But do I want to use either of these points that's touching? Do I want to go left or right from there? No. Where do I want to go from? I want to go from the midpoint. What is the middle of 1 and 3? No. 2. What is between 3 and 5?
4.
What is between 5 and 7? So at the midpoint, I go over halfway left, and the other is halfway to the right. Boom. So I go back to this red dot, half, 1 to the right, 1 to the left. There's the height of that rectangle. 1 unit right, 1 unit left. There's the height of the third rectangle. So what are the heights? The height is f of 2, and the other height is f of 4, and the other height is f of 6. Now, somebody might ask themselves, is this going to give me a bet? We already know the real answer, don't we? The real answer is 40. Let's see if this is better than problem number 1 or problem number 4. Let's see if this is closer. Area is going to still be approximate. The width I factor out is 2. F of 2 plus f of 4 plus f of 6. All 3 numbers we've done before. What is f of 2?
23 over 3.
How much?
23 over 3.
23 over 3. What's f of 4?
Maybe 23 over 3.
And what was f of 6? Yeah, that makes sense. Both of those was it. 5 exactly? That's 15 over 3. This was 23 over 3, you said?
Yes, sir.
So if I add those all up, I got 46 plus 15. That's 61 over 3. 2 times 61 over 3, which turns into 122 over 3, which I guess I want to see the decimal. That's approximately 40.
Wait, 122 over 3?
122 over 3?
No?
Yeah, 122 over 3.
Oh, I see what you did. Okay.
But I'm dividing by, I'm doing the decimal now. 40.666. Check that out.
So it's more accurate.
Very accurate, isn't it?
So
The midpoint probably is one of your better ones to do.
why do we have to like the other?
It's concept. It's concept, sorry. Frankly, once you know how to integrate, why would anybody do Riemann sum? Think about it. Why would anybody find the derivative based on slopes between secants? Just do the derivative, right? But those are the concepts. It's where it came from. All right?
We have to learn these because of the concept?
Yeah, because that's how they could ask you on the test.
What do you mean? How will we?
On the AP test, they could say, here's the picture. I want 4 rectangles with left Riemann sum.
Okay.
And so you got to, not even telling you what he says, I want 4 rectangles. Oh, you want 4 rectangles? Then delta x is going to be 7 minus 1 divided by 4. How many rectangles I'm going to use? That's going to become 6 over 4. That means I need the widths of 2/3. 2/3. Oh my God, I got to start at 1 and add 2/3 to it. And when I get done, I know, I say the same thing. But that's not this lesson. That's not today's lesson.
Actually ask us that.
Yes.
And they
Yeah, you'll have a calculator.
So is the calculator allowed for all portions of the test?
No, you have half that's not calculator allowed.
I looked at them all.
But most of the time, it'll say, give me 4 rectangles, and it might have 24 different things, so it's only going to be 24 divided by 4 is 6, so every 6. You want it to add fractions necessarily. Anyway, here goes. So if I'm going in the middle and the width is 1, here I got to do is the middle, if the width is 1, there's the width of 1. Where's the middle at?
1.5.
It'd be 1.5. And I go up, I touch the function, and I go halfway left and halfway right. There's the height at f of 1.5. So we're going to need that. So then I go and do a width of 1 again. Go all the way up. But I need half of that. Touch the function, go halfway over, halfway. Look how much more accurate that's going to be. Now, I would prefer that you finish this picture. You know, go ahead and go to from 3 to 4, all the way up. Go to the middle of them, that's the midpoint. Touch the function, go halfway unit, there it is. I may as well finish it up. Between 4 and 5, halfway over, halfway, between 5 and 6, halfway over, between 6 and 7, halfway over, there they all are. So I know the area is approximately 1 times 1 is the width of each of those. Width of 1, width of 1, width of 1, width of 1. There's 6 of them, I think. 1, 2, 3, 4, 5, 6. And the first one was f of 1.5. The next, f of 2.5 plus f of 3.5 plus f of 4.5 plus f of 5.5, and the last one, f of 6.5. None of those have been done in our calculator. Yeah, we had a couple maybe.
No, they've all been done.
We've done them all in the last problem? So now, do I got to spin the wheel to get some of you guys who haven't participated? I don't even think I've seen you look up. I'm trying to figure out what is going on with some of you guys who I don't really see involved. Are you okay with, am I being too easy that you're able to pass my class without having to struggle or act alive? Maybe I'm too much of a wishy-washy teacher. Maybe I need to be more stricter. Hold you guys all accountable to the high standard of calculus. You've already been helping. Obviously, I'm not talking about you. Well, I appreciate your input that you have given me. But right now, I just need f of numbers, and everybody should be able to give me one of them. So everybody should be doing it, so if I call your name, you got it. So here goes. I'm not going to spin the wheel. I can randomly do it in my head. What is f of 1.5, Alyssa? Yeah, I can't do it in my head. Or look in the notes. We just did it on the other problems. We're going to do decimals now?
Oh, hold on.
Whatever. I'm good. 7 point.
Or 29 over. Oh, no,
No, I'm okay with decimals. 7.25, you said?
Yes, 7.25.
We're going to do decimals. And there was nothing else after 0.25.
No, sorry.
Well, the halves came in the midpoints. That's why they were in halves. That's why they're all 0.5s. That dotted line is always in the middle of the two. Won't always be that way, but it is in this case. It wasn't for this problem over here. The halves landed up perfectly on whole numbers. But this is not a pretty problem. All right. Tony, what was f of 2.5? You got a calculator, don't you? Oh, speaking of calculator, since you're not going to the district meet, turn in the UIL calculator. Okay. Oh, yeah, you have the older one. Yeah. Wish you were going.
Where's he going to be at?
Brownsville. Yeah, you can't go there. Rivetta High School. You don't have a calculator with you right now? You don't even have a graphing calculator?
No.
What kind of phone do you have? You could have downloaded this program. What?
What money?
He's got money. See, not having a calculator is not an excuse, either of you. You could be working with somebody who has one instead of just ignoring this.
I would say 7.9, probably the 7.916.
7.916.
I don't know if that's it.
Yeah, it is.
All right.
Oh, I'm so
Caleb, f of 3.5.
It's the same.
Same?
Sounds like calculator.
Gilbert, f of 4.5.
4.5?
Yeah.
Is it 7.5?
7.25 again?
You got 7.25.
Sandy, f of 5.5.
5.5? 5.9166. Wait. Yeah.
And last, f of 6.5. Michelle, f of 6.5. She's real tired. I haven't heard her hardly. I haven't even heard her speak at all.
Not today. Is that a 5.9166?
That was for f of 5.5.
No, but I'm asking, is it a 5?
That's what they say.
Yeah, it's 5.
3.016?
No, 3.916. I thought that was 7.
3.9166. Okay. So there's my 6 of them. 1, 2, 3, 4, 5, 6. All times 1. Adding those up. That's going to go to, who have I not called on? Abby. I mean, I'm sorry. Madison. Yes, I did.
There's been all year.
I've been pretty good. I've been pretty good. I've been thinking that A comes before M, so Abby, but I messed up right now. I gave her the. No, I didn't call you. I didn't call it Adam. I don't have Adam in here. Abby, I called you Abby.
So the last one's 5.1991.
6.6. Yeah, we know that. We're adding all these up.
Yeah, 3.8166, right?
Yeah.
And then what's it?
Add them up. What do you get?
And then it's not to 39.8652.
Wow, 86. That is so close to 40. And we didn't even make them smaller. Well, was small. Yeah, okay, we did make it smaller. We were pretty good at 40.66. And look at that. That's really close. Went the other way, though. This was over and this is under. I don't know why I went. And look what he was going to want us to do, which we won't. Oh, no, he didn't have us do. I thought he was going to have us do a half. Thank God. I was not going to do it.
Sound like these
I wasn't going to do a half in the middle. That'd be hard.
are. I have to end up 1.4.
It'd be, we could do it if you took like 20 minutes. The last Riemann sum is not with rectangles. It's trapezoids.
I don't like that.
No, it's actually kind of cool.
Okay, cool, but
No, be open-minded. It's not that as bad as you think. We are going on the interval from 1 to 7, and he wants the trapezoid is to have a height of 2. Well, let me share with you what that means. When you've got a trapezoid, like that, the height is this value right here. There's your height of your trapezoid. And if your trapezoid looked like that, where's your height? Same place, isn't it? Right there. Well, we're not doing these trapezoids here. We're not doing that one. We're doing this one here because we're going to stand it up. We're going to stand it up. So the height is right here. The height is the same thing as the width of the rectangle. So, don't fear. He wants the height of the rectangle to be 2. So I'm going from 1 to 2, or 1 to 7 first, 1 to 7 like I did before. Mark off the width of 2. That's the bottom of my trapezoid. If I connect this up to the function, look at this. This point and this point get connected. There's your trapezoid. Isn't that cool?
That's even better.
Yeah, you're right. You're right. And so if I go to the next 2, there's the bottom. You all get a car. And now I connect these 2. Michelle nailed it. Trapezoidal rule actually is a better approximation than rectangle Riemann sum. I make my bottom of the trapezoid. I go up, I connect each leg of the trapezoid. Well, it said the height of the trapezoid was 2. That becomes the width of this piece here. So here's another one, width of 2. So both legs connect to the function. And I connect both those legs together like that.
Oh, so you connect the legs.
Yeah, you're connecting the top of the legs.
Straight line?
Yeah, straight lines. So now the hard part is, what in the world is the area of a trapezoid formula?
Isn't it
1/2
base times height?
It is 1/2 base 1 plus base 2 times height. So if you look at the left-hand trapezoid, this is my base 1. This is my base 2. You see that? The height of this is base 1. The height of this is base 2. So if I just do that first one, that area will be, let me see, I got 1/2 pulled out. Base 1 comes from f of 1. Base 2 comes from f of, no, yes, f of 3, you're right. And the height of this trapezoid is how much? 2. Which in this case, 1/2 times 2 cancels out. All your left,
Choose f of 1 and f of 2.
it was the left side of the trapezoid and the right side of the trapezoid. Those are your bases of the trapezoid. If you look at it over here, look at it here, base 1, base 2. So using that same function, what is f of 1? We've never done f of 1, have we? Yes, we did. Left-hand sum. Left-hand Riemann sum. We've done f of 1.
20 over 3 before things up.
20 over 3. And then we did the 3. Same problem. So that one trapezoid all by itself is 44 over 3. That's just one trapezoid. Let me just call that.
Do that over and over again.
Well, we got 2 more trapezoids.
But what if it's
Never mind, this is not better.
Yeah.
Well,
I'd rather do midpoint.
I will show you how to abbreviate this, but right now I just want you to visualize this. The second component is 1/2 times base 2 plus, I have to call it base 3 now, times height. Which, by the way, isn't height still a 2? Doesn't it still cancel out the 1/2?
Yep.
And am I still looking at then a base 2 plus base 3? And you already did base 2, you told me,
Not base two.
Uh, I'm sorry, base 3 and base, yeah, so that's base 3, well, I called it base 2, which is f of 3,
Yeah.
and then base 3 is f, or,
F of 5.
hold on, f of 2 and f of 3. Base 2, base 3, you got me confused.
Sorry, you got me confused.
Base 2 is still f of 3, base 3 is f of 5. I knew somebody was saying it. So you said f of 3 was 24 over 3. What was f of 5? 20 over 3. Oh, that gives us the same thing. 44 over 3. One more trapezoid. Let's see if you visualize it. There's base 3. This is base 4. Base 3 was f of 5. Base 4 is f of 7, or 6. Sorry. So, area is equal to 1/2 base 3 plus base 4 times the height. The height's a 2, cancel out the 1/2. Base 3 was f of, somebody? 5 plus f of 7. F of 5 you told me was 20/3. F of 7 is, we did that on the last problem. F of 7, the right side.
8/3.
Yes, 8 over 3. That turns into 28 over 3. So now I got 3 of them. So my area total will be approximately 44 over 3 plus 44 over 3 plus 28 over 3. Remember, the exact answer is 40. That's 88, 98, 108, 116 over 3. Did I get it right? 88, 98, 108, 116. What is that approximately? 38.666.
So we should do
Less
10
than the other one.
That wasn't bad though. Now, let me share with you the secret to trapezoidal rule here. Look at here. The F1 got used 1 time. The F3 got used twice. See that? The F of 5 got used twice. The F of 7 got used once. Notice the 2 on the outsides got used 1 time. The other 2 in the middle got used twice. So does this formula look like it could make sense? Area is approximately, factor out the height, divide it by 2. I have an F of 1. I have 2 F of 3s. I have 2 F of 5s, and I have 1 F of 7. Yeah, we could have done that. By the way, that's the official definition. It's a trapezoidal rule. 1 on the end, you always get 2 of the insides. Always. Yeah, it is weird.
Times h over 2?
Yeah, because I factored out the height, which is a 2 over 2. It goes away anyway. Yeah, in this case, it goes away anyway. So you would have F of 1 plus 2 F of 3s plus 2 F of 5s and then 1 F of 7.
But sir, what if there's like an odd number of
There never can be. Trapezoid always has a base 1 and a base 2.
Oh, that's right.
Sir, I'm tired.
Sir, over
You were what? You were what?
I was sitting behind Mikhail and Jay.
Who's Mikhail?
He's not in your class anyway. So, apparently there exists a kind of geometry where parallel lines eventually meet.
Sure they do. Look at a railroad track in the future. Railroad track is parallel, but then if you look out in the distance, every artist who uses the other side of the brain, they know it. Van Gogh knew it. Rembrandt knew it.
I don't know.
That the railroad tracks in the future,
In the future.
yes,
Then they're not really
in the far distance, they draw it as touching. Matter of fact, there's a name for where they touch.
Yeah.
Ideal point.
Oh yeah, I remember that. That's how to do with like art and theater.
Exactly.
Before he
There
died.
you go, see? Anyway,
No, but apparently it has like a certain name. It's like some I don't know, perpendicular geometry. It's not perpendicular, but something like that.
it's non-Euclidean,
Yeah, that.
yes.
You're like this year math is just like flipping itself on its head.
I hear ya.
Infinity exists. but-
All right. He wants us to do trapezoids with a height of 1, from 1 to 7.
Can we use the other
What
formula?
number is that?
Okay, let's first draw the picture out.
Okay.
I agree with you. Why do we want to break it into so many trapezoids? You don't want to write all that out, do you? So we know we have one of the f of 1s, because that's connecting to there. We know we have one of the f of 7s. It's being used, it's getting connected there. All the other two, if you look carefully, this second vertical gets used for this trapezoid and it gets used for this trapezoid. You see it? How it's being shared? This one's being shared. This one's being shared. This one's being shared. So I will use that new formula. Area is approximately the height of the trapezoid divided by 2. Always will be the height of that trapezoid divided by 2 because the formula is 1/2 base 1 plus base 2 times height. So I'm pulling out the height over 2. Here it goes.
Oh, so you're using that new formula because it would take longer to do it more like
It would take longer to do all 6 trapezoids. You can do that. The AP test never gives you that many trapezoids. They usually only give you 3. So if you know the secret formula, you can use it. If you didn't know it, you still can get the right answer.
Okay.
So I have one f of 1s. And now, if the width is 1, it ends up at a 2. It ends up at a 3. It ends up at a 4, a 5, a 6, and a 7. So I have 2 f of 2s, 2 f of 3s.
How do you determine that again? Repeat.
About, to determine what? Look at,
It's because
they're sharing a side. They're all sharing a side except for the last one and the first one. She's not back yet. 2 f of 4, 2 f of 5s, 2 f of 6s, and only 1 f of 7. So maybe it's not as bad as you thought. Because this one is pretty lengthy, but it's all simplified, nice and pretty. What was the height in this problem? 1, so it's still a 1/2 then. That doesn't go away this time. What was our f of 1? Decimal or fractions? 20 over 3. 2 times, what's f of 2? That's true. That's a good idea. 23 over 3. 2 f of 4s?
Wait,
2 F of 3s, yes, I'm sorry.
Oh, then 24/3?
Now 2 F of 4s. Now 2 F of 5s. 2 F of 6s.
13/3.
I don't remember that one. And then 1 F of 7. He said that was F of 6.
I thought it was 15/3.
That's what I said.
Ye- Oh, okay. I said I didn't, I wrote 13.
Yeah.
I said I didn't remember hearing 13/3.
That's not Sandy.
What's up?
Wait, it's not.
Finish doing what?
15.
PEing. F of 7? F of 7's but 8/3? Okay, so if I simplify again, 1/2 times 20/3 plus 46/3 plus 48/3 plus 46/3 plus 40/3 plus 30/3 plus 8/3. That gives me 1/2. 20, that's 40, 50, 66, what's 88, 9. Add those top numbers. 20 plus 46 plus 48 plus 46 plus 40 plus 30.
Is that a 30/3, sir?
Yes,
And before that is what?
238.
40/3. 238
over 3.
over 3, that gives me 238/6, which is approximately what? Wonder how close this is to 40.
Wait, 238 over, okay, sorry. You wanted to know what? How close is it?
Yeah, what is that one? That's,
39.66.
wow, you can't get better than that.
Well, isn't it only, 366?
Yeah, you only had,
Well,
you
it's
should,
like a long number, so then wouldn't it be 39.7?
I don't know, what were your decimals?
It's 39.66666667.
Then I'd leave it at 666.
Okay.
You could make it 667 if you want, units squared. So that was pretty accurate, guys. Look at that. I'm only 1 unit trapezoid, and it's almost perfect. All right. He spends time taking all our answers and writing them all out and stuff. I don't think we're going to do that. We got some more to practice with, but I think you can do, well, I don't like the homework. Well, yeah, actually,
Wait, what?
Can you do the homework already, or? Can we?
tell you what,
Yes.
just try to do the first 2.
Wait, did we take the ones that we did on the board?
Yes, I'll try.
I haven't recorded it.
I really will, because I don't.
Huh?
These?
Yeah, I haven't posted it yet.
Oh, okay.
It's because we haven't done 11 or 12.
Oh, we're missing 2. I didn't know we were missing 2. All right, we'll do them first thing, Wednesday, and,
Oh, so the SAT, it's Wednesday.
Wednesday. Oh, yeah, we may not be in here.
Oh, yeah.
Friday.
I may be dislocated.
Oh, PSAT? No, the SAT. This year the district's hosting it for the juniors.
Wait.
Huh?
We get it for free.